Students, today our topic is composites. The materials available to the world, that means including the timber, stone, cement, metals, plastics. Nowadays another class of materials, they are called composite materials, and they are coming up very fast. The composite materials are of a family that is likely to provide the engineers with materials having tailored to mate properties in combinations unknown or impossible to achieve in simple materials. By definition, a composite material is a combination of two or more chemically unlike materials with distinct boundaries between them. In the broadest sense, most of the materials used today are composite materials to some extent. Metals and alloys are composite in the sense that they contain impurities, alloying elements, and different phases. Engineering materials like cement, concrete, and plastics contain other materials in the form of additives or fillers, etc. However, in the present context, a composite has been defined as a combination of two or more materials that has properties different than its constituents. Composites as the class of engineering materials provide almost an unlimited potential for higher strength, stiffness, high temperature capabilities over conventional materials. Composite materials, as I have discussed already, are better than the properties of the individual materials from which they are made. Now, most of the composites were first made by nature itself. For itself, bamboo, wood, and skin, muscles, etc. The reason for the occurrence of composites in nature is perhaps due to the fact that the means of judicious choice and distribution of two or more phases, we can optimize the properties, and actually optimization is the key to survival. The structure of a composite material clearly shows the presence of two different materials. The base material, which is present in the larger amount, and it is called the matrix, and the other materials is sometimes preferred as reinforcing phase. Now, it could be present either in three-dimensional particles or two-dimensional layers or long fibers. Now, in the present context, composites have been defined as a combination of two or more materials. I have discussed this earlier, that has properties different than its constituents. The two materials, one which is called a matrix and another one which is called a reinforcing material, and with the help of those two materials, a composite is formed which has a better property than these two. Now, as per the classification of composites, depending upon the size and shape, that is the second or reinforcing phase, composite materials can be classified into following groups. That is agglomerated materials, which are cement, concrete, and laminated materials, that is plywood, sun mica, reinforced materials, that is reinforced cement, concrete, nylon reinforced rubber, or dispersion reinforced composite, that is fibers in metals or non-metals. So all these are classified materials, And as per the dispersion reinforced composites is confirmed. So when a soft and ductile metal matrix is increased by the uniform dispersion of hard phased particles, the resulting material is called dispersion reinforced or strengthened composite. The second phase material are generally oxides and carbides. I am talking about this one. The second phase materials are oxides and carbide, which are insoluble and incoherent with the matrix. The diameter of the second phase particles varies from zero point 0.1 to 1 micron as they are dispersed in volume contraction of 1 to 15 per second. In dispersion composites, the matrix is the major load bearing the constituent, and the fine dispersions act as a barrier to the motion of the dislocations in the matrix. Now, alumina reinforced aluminum composites are obtained by pulverization of aluminum metal to powder. So this is a brief overview of dispersion reinforced composite. Then let me talk you about particle reinforced composite. In this group of composite, the matrix is reinforced by hard particles of three-dimensional shape. The volume of the second phase particle is greater than 20% and the particle size is more than 1 micron. Therefore, the particle reinforced composites will have greater volume fraction and larger particle size as compared to the dispersion strengthened composites. Now, some example of particle reinforced concretes are cemented carbides and some other. And this application of cemented carbides, let me tell you, metal cutting equipment, one of the major application of cemented carbide. And cemented carbide are used as many grinding application in the form of balls, grinding cylinders, and also milling liners. So sorry for the interruption. Now let me talk you something about fiber reinforced composites. In fiber reinforced composites, high strength and high modulus fibers are incorporated in metal or ceramics or in plastics material. Composites of this group can be achieved or it can achieve, in other sense, unique combination of properties such as higher stiffness, higher specific strength, elevated temperature, high fracture toughness, etc. And properties of fiber reinforced composites are determined by the properties of the matrix and the reinforced fibers. Cyber reinforced composite material consists of three main constituents, namely matrix, fibers, and the interface. The main purpose of the matrix is to transmit the load to the fiber, which is the principal load bearing constituent. When uniform and continuous fibers are unidirectionally dispersed throughout the composite, then the composite strength will depend upon the strength, volume fraction, and the orientation of the fibers. In addition, composite properties will also depend on the nature of the bonding, the chemical activity and diffusion between different matrix and the fiber. Now, in the context of the composite, I have already talked so much. Now, let us, hear about some fiber reinforced plastics and glass fiber reinforced plastics. These are some important composites to be named of. And this is all for now, and we will discuss again on this very topic in my next video. Stay safe, stay inside, and study well. Thank you, everyone.